We are going to do a quick review of inverse functions in preparation for studying the inverse relationship between exponent and logarithms. So first, recall that if a function is f of x, the inverse is denoted f with a -1 exponent, and we read this expression as f inverse. The relationship between inverse functions is really special in that one function undoes the other. So if we were to plug one function into the other, which is composition, we would find that f of x, we would find that f composed with f inverse of x is equal to x. And this relationship works in both directions. So f inverse composed with f is also equal to x. Now I'll start off with a very simple example of an algebraic function, specifically a linear function. Let's say that we start with the function f of x equals 2x minus 3. It's a linear function. It's going to be very straightforward to invert. The first step is to replace f of x with y. Then we have 2x minus 3. Now we're going to switch our x and y's. That's the inverting step. So we have x is equal to 2y minus 3. And now what we do to find the inverse is we solve this function for y. So let's add 3 to both sides. And then we're going to divide both sides by 2. But instead of calling this y, we're going to name this f inverse of x so that we're using the same function notation that we started with. Now, I want to also verify that these are inverses. And so let's test f composed with f inverse of x. And remember, what this means is we take f, our first function, and we plug in the inverse into x. So we'll have 2 times x plus 3, all divided by 2, minus 3. So we've taken f inverse and plugged it into our first function, f of x. I'm going to erase this down here to make some space. The first thing we do is simplify. And we can see that this 2 and this 2 cancel out. So we're just left with x plus 3 minus 3. Plus 3 minus 3 is 0. So we're just left with x. To be truly rigorous, we should test the alternate path. So let me erase this step, and we'll have f inverse of f of x. And so this time, I'm going to have 2x minus 3 plus 3, all divided by 2. So I've taken our first function and plugged it into the function that I've already erased. But luckily, we had this up here, which was the second function. Hopefully that wasn't too confusing. In any case, we can simplify. 2x minus 3 plus 3 is just 2x, all over 2, which is equal to x. So we've now verified that these two functions are in fact inverses.